We're going to talk about how to find the x-intercept of a straight line. We spend a lot of time thinking about the y-intercept of a line. If I draw a quick line like this, and the equation of the line might be y equals 2x plus 6, quite an easy question would be find the y-intercept of the line. Well, because lines take the form y equals mx plus c, where c is defined as the y-intercept, we can literally just look at y equals 2x plus 6 and say, well, this is c, therefore 6 must be the y-intercept. So it's really easy just by looking at the actual equation of the line, because c literally represents the y-intercept. However, it's more rare to be asked about the x-intercept. In other words, the point on the line which crosses through the x-axis. We can't just look at these numbers like 2 or 6 and say, well, that's the x-intercept. We have to do some working out here. Okay, so if we're looking at the x-intercept, it's important to think about what defines the x-intercept. So here's the x-intercept in terms of visually looking at it. Okay, what is true always? Always true on the x-axis. What is always going to be true no matter what point I pick, what is always true on the x-axis? The answer is that the y-coordinate of any point on the x-axis is always 0. It has a height of 0. Any point you pick on this x-axis, the height of the coordinate is 0, therefore the y-coordinate itself is 0. So if I'm thinking about the x-intercept of the line y equals 2x plus 6, what I'm going to do is recognize that at the x-intercept of the x-axis, y is 0. And all I do is substitute 0 in for y. So I won't write y equals 2x plus 6. I'm going to write 0 equals 2x plus 6. And at this point, all we're doing is solving a two-step equation. If you don't know how to solve a two-step equation, you might struggle a little bit here, but if you do, then you're basically the answer. We want x on its own, so I'll bring 6 over to the other side by subtracting 6 from both sides. So minus 6 equals 2x. And one final step to get x on its own, I'll divide both sides by 2. So minus 3 is equal to x. So this point here has an x-coordinate of minus 3, and then clearly it will also have a y-coordinate of 0, just like every other point on the x-axis. Okay, I can do another one. I'm just going to make up the equation of some line here. We can say this line has the equation y equals 3x minus 15. Okay, and I want to find out the x-intercept, the point where it crosses the x-axis. Okay, so once again, I'm going to recognize that on the x-axis, at the x-intercept, the y-coordinate is always 0. So I'll call y 0 right now. So I'll say 0 equals 3x minus 15. Again, I'm solving a two-step equation. I'll add 15 to both sides, so 15 is equal to 3x, and therefore x is equal to 5. So this coordinate here will be 5, 0. I'm thinking about ways the question could be a little bit different. They might not give it in the typical form y equals mx plus c. They might give it in a different form, like for example, y plus 2x equals 40, but it's almost like in this form it's actually easier. Once again, if I'm looking at the x-intercept, I'm going to call y 0. Y is always 0 on the x-axis, so I'll call it not y plus 2x but 0 plus 2x equals 40, 2x equals 40, and finally x equals 20. So the coordinate of the x-intercept in this case will be 20, 0. Alright, so that's a quick couple of examples of how to find the x-intercept.